Meters this cheap don't do this. Really impressed me. The measurement that we're getting there is the amount of voltage drop across the diode. All right, folks, welcome back to another adventure in the garage. For all of you that are new to the channel, my name is Luke, and today I'm going to be helping you do an in-depth tutorial of all of the different settings on your WeePro. They are not a sponsor of the channel. This is model WeePro850L Lima. Comes complete with a backlight and a hold button. Gotta love it. First impressions of this meter so far. It's cheap. It's a bestseller on Amazon. Amazon is an affiliate of the show. Go check out the link in the description. This is great. Like if you have a kid that is getting into electronics and you want to help them support their hobby, or maybe it's for school or something like that, I think something like this is perfect because it's cheap and most of the functions work. You know, God forbid something happens to it, it gets dropped, broken, stolen, whatever, you can replace it very easily. But keep in mind that it is cheap and it's a tool, and it's a cheap tool, and cheap tools don't last and they're not reliable. So keep that in mind. Other than that, the only other thing I want to say is if you're getting this meter specifically for the transistor testing function, that's the HFE and these portholes here for the NPN and PNP. Any meter that I've tested that has this functionality, it does not work. And I'll go over that when we get to that setting. Right off the bat, I would recommend something like this multi-function tester. It's like 25 bucks or something like that. Link in the description. This thing is great and it's way better than anything that you'll get that's built into a multimeter. And I think they even have an updated version of this now that looks really great. So if you're testing transistors, get a dedicated transistor tester and it'll save you a lot of heartache and headache going down the road. Let's go ahead and get started. I do love the backlight on this. That's just great. It's bright, very bright, vibrant, doesn't stay on for very long though. So that's a little disappointing, but it's a battery saver, so that's great. Let's go ahead and go through these settings. Something that I do like, I want you to break this meter down into, let's see, 1, 2, 3, 4, 5, 6. We've got it broken down into 6 sections. I hope that's not too overwhelming. But these first two here, this is for volts AC. And because this is a manual ranging multimeter, okay, I want you to think this setting means I'm going to test volts AC up to 600 volts. I'm going to test volts AC up to 200 volts. Another mindset that we want to have when we're working with a meter like this is we want to start on the biggest setting and then work our way down. So in this section, our biggest setting is the 600 volts AC. So we'll want to start there so we can get an idea of what kind of voltages we're looking at. Man, that backlight, I wish it would stay on. And we can just take a measurement here. Okay, so we're seeing, man, that is not accurate too. Well, yeah, no, I think that's accurate. Let's double check. I think I have that output at 114. I mean, this meter is so cheap. The fact that you really get any kind of a measurement at all is kind of a miracle. Let's just take a little look and see what we're getting here. Okay, we're coming in just under 114. So we were showing like 114, 115. But then what we can do, man, this backlight's terrible, is we can put it to that 200 volts AC. Now we have a decimal point. Now we can read. Maybe I can illuminate the display with the light bulb. There we go. Can you see it now? Technological. Let's see, what are we getting for a reading? Okay, so now we can see 115.4, 15-ish right in there. It's not a true RMS meter, which if you don't know what that means, that's okay by me. But I hope you can see kind of the process that we did there is we started big. We started with the biggest setting of 600. We got a feel for the actual number is of our circuit, and then we were able to dial it in. So because we were measuring 115 volts, We know that that's less than this 200 volts AC setting here. And so we were able to put it here to give us a more accurate reading. I always like to describe it as like, think of like a microscope. When we're taking a look at something under the microscope, we start with the microscope lens way back up here and everything in the picture is really fuzzy. And then we slowly zoom in and it gives us better clarity, better detail of what we're trying to look at. Same kind of deal with our meter. When it's in that 600 setting, the microscope's way up here, kind of a bird's eye view, kind of blurry. And then as we work our way down, right, it'll be more accurate. And you're gonna wanna think about that really for all your settings. This next section, so we covered volts AC. Now we're getting into current measurements. And this is saying, this is only rated for direct current. So don't measure any alternating current. Only direct current can be measured with this. And I'm gonna start at this 10 amp port. So for that, we're gonna move to the 10 ADC port. I have no clue why it's labeled the ADC port because it's not rated for AC current. It's only rated for DC, but that's okay. In the land of cheap meters, you can pretty much do whatever you want. And as long as you put the price tag cheap enough, people will buy it. And that's all that they're worried about is moving units at this point. So let's go ahead and put this to 10 amps DC. Let's go ahead and get DC circuit going on here. Got some examples. Now, when we're measuring current, we always want to keep in mind that we're going to be measuring in series with our circuit. So the way I like to explain that is we're going to use the leads, the test leads of the meter are going to act like jumper cables, and we're going to complete our circuit with the meter leads. I'll give you an example here. We'll take a look. What's going on here? Let's get some power. Okay, so you've got a live circuit here. So what I'm gonna do, complete the circuit with my multimeter leads. Okay, and then we can see, I know it's hard to tell on that display, that's saying 2 amps of current, that light bulb's drawing. And then we're gonna do this motor over here. Okay, and we see it's reading 0.45. We would say that's 440 milliamps of current. Instead of saying 0.45 or 44, we would move into units. We would change our units to milliamps. And so what you're gonna notice down here is this port, they're trying to say this port's rated for 10 amps max current, and this port is rated for no more than 500 milliamps. So anything that we're doing that could potentially be 500 milliamps or more, we'll want to put the red lead into this port. But our motor here is under 500 milliamps. It's only at 450. So this motor would be safe to have for this port. However, this is where it gets confusing because it is a very cheap meter. The next setting down is only rated for up to 200 milliamps of current. 200 milliamps of current, okay? What we really need to think about is that we shouldn't change our setting and our port over until we're measuring something smaller than 200 milliamps of current, if that makes sense. So this is over 200 milliamps, so we have to put it on the 10 amp setting, which means that we have to put our lead in the 10 amp port, which is not fused. So be very careful or you could barbecue your little meter. Let's go ahead and let's get some smaller loads going here. We've got some resistors, make for great, very precise loads, and great for practice. Careful, they're only rated for a 1/4 watt generally. So what I'm gonna do, I'm gonna stay big and work my way small. So for now, let's try to think about this as a real world scenario. I necessarily might not know the value of these resistors or how much current they're going to draw. I'll leave it on my 10 amp setting, my lead in my 10 amp port, and I'll go ahead and make a measurement. And I want to see under 200 milliamps of current before I change my settings. Let's go ahead and do that. Okay, 120 milliamps is what I got there. So I can put it to the 200 setting, move this little guy back on over to that. And now I'm in a milliamps unit of measurement. So I should see 120 pop up on this screen here. Let's see it. Boom, there it is. And we have to the tenths. Nice, 124. And then we can keep going here. Okay, so this is only 12 milliamps of current. Let's take a look at our settings. The next setting down would be 20 milliamps. And I just measured a 12, so I can go to this up to 20 milliamps of current. And now I should be able to make that measurement, and I should be able to read it to the hundredths. And I can. Now I know, okay, it's actually 12.03 milliamps of current. That's great. We'll go on to this last example here. Ooh, and that is only showing 1.18 milliamps. So now we know that's less than the 2 milliamp setting. We can go ahead and set it to that, and we should be able to see it, I want to say, in the thousands. We can read it's 1.192 milliamps of current. And then our next unit of measurement down from that is going to be our microamp setting, and it's rated for up to 200 microamps, which is an incredibly small amount of current. Something that I don't really like about these cheaper manually selecting meters is because we're in this mindset of start big and work your way small. With the volt AC setting, you know, it starts big, works small. And then when we get to this next section here of milliamps, big is all the way down here. And then we have to work our way backwards. And the smallest number on here is this 200. And you would think that that would be the biggest number setting here, when actually that's a 200 microamp setting, and it's the smallest out of these. So you really want to pay close attention to the symbols and to the settings. Can really get tripped up easily. And then whatever you're reading can be really confusing. And if you're trying to do a project and do measurements and do your math with it, you could get lost very quickly. And don't worry, it's not just you. It is hard, really hard to see that display, even with all the awesome work lights that we got going on down here. Okay, so next setting is going to be, this is going to be your HFE or your transistor setting. And so for this setting, you're going to utilize this port. I have a transistor here. I'll get it tested with a dedicated tester. Okay, I know this is an NPN, and my Charlie is in port 1. So I'll take that, Charlie, and you're going to insert the legs of your transistor into here. Now, with the way that these work is you got to get them just right. And see how you get a bunch of different numbers? How sensitive it is? It's not just you. These transistor testing ports are super terrible on any meter that includes them. Don't waste your time with them. It's not worth it. So we'll go ahead and move on to the next one, which is going to be continuity. That's what that little speaker symbol is for. That's going to just tell us is anytime something's got flow, right? Anytime the electrons can flow through some kind of conductor, we should hear a tone from the meter. We do. That's letting us know that there's flow through the wire. Does it mean that the wire is good and everything's perfect and the circuit should work? No, it does not, but it does tell us, like a good example that I like to use for it is, it's a great setting for figuring out who goes where, right? What goes what, who goes where. So if I want to figure out, okay, that wire doesn't go to there, does it go to here? Yes, the black wire goes to here. So that must mean the red wire goes to there. And so if you have more than one wire, you've got a couple of them, you know, or a lot, it can help you identify who's who in your wire bundle. Okay, so next we've got the resistor settings. And again, we want to think big and work small. So the biggest setting we have for our resistors is 2M. And think of, this is all metric, right? So here in the US, I know 60% of my audience is from the US. We're terrible with the metric system, myself included. But 2M is 2 mega, or think of 2 million. And then 200K K is for kilo or for thousand. So 200,000, 20,000, 2,000, and then 200. And then we're in the mindset of up to. So this setting up here can read up to 2 million ohms. This can read up to 200,000 ohms, and so on. So I've got a bunch of resistors, and we're going to work through this wheel, do a bunch of examples because it can be a little confusing. It took me a while to understand it too. I also have a bunch of videos going through all of these test settings on all these different meters, re-explaining it everywhere that I can think of. And when we're testing resistors, it doesn't matter the direction of polarity with our leads, okay? We can do either lead to either side. So we'll utilize this little H here as a hold button. That'll hold our measurement for us. So what this is trying to say here, we're in the millions setting. So this doesn't mean 1.037 ohms. This means 1,037,000 ohms of resistance. Okay, we're gonna keep going. Okay, next up, 0.097. We're in the million setting. So what does this mean? Well, this means 97,000 ohms is how much we just read there. Now 97,000 is less than 200,000. So if I want better resolution, a more accurate reading, I can put it to that 200K. I can remeasure it. Take a look at what we got going on here. And now I know, okay, it's not just 97,000 ohms, it's 97,600 ohms. We'll keep going. We'll start with the M. Okay, we've got, so what would that be? Like 9,000. So we can work it down past the 200K, past the 20K. Okay, so we're at the 20K setting. It's still more than 2K, so we can't go down there. But for the 20K setting, that means, okay, 9,880 ohms is what we're reading. What if we did go past the 2,000 setting or the 20,000 setting? What will we get? We should get a 1, basically meaning it's out of limits. It's an error message that it's sending you, and it's telling you that you're on the wrong setting. Let's do one more for good measure, and we'll do this one. Okay, we're on the thousands, 20,000 setting, and we have a 9. What does that mean? Well, that's telling us 90. So we can keep walking this down. Okay, well, it's actually 98, 99. And then if we want to get the most accurate, we can go to this 200 setting. And that's the most accurate setting we have for how low this is. It's saying it's 98.4 ohms of resistance. So there's all your resistive settings. There's one hidden extra goodie in here. And I was actually really shocked how well this works. This is your diode setting. So your 2K and your diode setting are shared. And check out how cool this is. Meters this cheap don't do this. Really impressed me. The measurement that we're getting there is the amount of voltage drop across the diode. Okay, that's a whole separate video, but usually cheap meters like this will not give you that value. So that's really impressive. What we want to see when we're measuring a diode, we're going to measure it in both directions, but in one direction, we should have between 500 and 800 millivolts of voltage drop to indicate that it's good. And then I'll press that hold button, we'll let that go. We'll test it in the other direction. And what do we have here? We should get that 1 should remain on the screen. And it does. That means that its testing is good. And then a little bonus that I always like to do, a lot of the meters can't do this, especially these lower end ones. But I always like to see if they can light a white LED light, and it can on the diode setting. So that's always fun. That's a good time for everybody, right? All right, and then our last section here is gonna be our volts DC, and it's gonna hold the same rules that we've been going over everything else. We always wanna start at the biggest number and work our way down until we know what voltages we're working with. Let's bring up something very familiar to everybody, a 9-volt battery. And when we're measuring DC voltage, the polarity of our leads does matter. We want to have the black lead to the negative sign and the red lead to the positive sign. And look at that, we're getting a 9 and then kind of a 10, okay? But we're the furthest away, we're at the 600. So what we can do, let's see if we can hold this here and then walk down this meter. Okay, now we're to the tens, it's really 9.3, 9.4. Now to the hundreds, 9.44. And then the next setting there is a 2. And that would be out of limits, so we should see a 1 if we go to there. Out of limits, gotta go to the next one up. Boom, there it is. And then you can hold that. And then you can hang it on the fridge. You can tell your friends and you can show your mom, hey, I got 9.44 volts on the battery. Anyways, I hope you all enjoyed this. Go check out some of my other videos. I got a bunch. If you're having a hard time with electrical testing, I got so many videos. I'm going to put up the playlist with every different multimeter available. I've got over 30 videos on just multimeter testing. Catch you on the next one.